Hello everyone. Today we have to solve problems on hyperbolic functions. This is sum number 1. If sine of theta plus I phi is equal to tan alpha plus I sec alpha, then show that cos 2 theta into hyperbolic cos 2 phi is equal to 3. Here sine of theta plus I phi is a complex number and its real part is tan alpha and imaginary part is sec alpha. And by using this relation we have to prove cos 2 theta into hyperbolic cos 2 phi is equal to 3. Let us solve this sum. What is given? Sine of theta plus I phi. This is equal to tan alpha plus I sec alpha. This is given. Okay. Now we can apply this formula. Sine of A plus B is equal to sine A into cos B plus cos A into sine B. Sine of Ix is equal to I into hyperbolic sine x. Cos Ix is equal to hyperbolic cos x. Cos 2 theta is equal to 2 cos square theta minus 1 and hyperbolic cos square phi is equal to hyperbolic cos 2 phi plus 1 divided by 2. We have to apply these formulae to solve this sum. Okay. So first of all, expansion of this sine of theta plus I phi. That can be written as sine theta into cos I phi plus cos theta into sine I phi. This is equal to tan alpha plus I sec alpha. So this can be written as sine theta into hyperbolic cos phi plus I into cos theta into hyperbolic sine phi. This is equal to tan alpha plus I sec alpha. Okay. Real part of left hand side must be equal to real part of right hand side. Okay. This is real part. And then imaginary part of left hand side is equal to imaginary part of right hand side. Hence we can write tan alpha is equal to real part, that is sine theta into hyperbolic cos phi, and sec alpha is equal to cos theta into hyperbolic sine phi. Okay. Now sec square alpha minus tan square alpha is equal to 1, right? Cos theta hyperbolic sine phi square of this minus sine theta into hyperbolic cos phi, its square is equal to 1. Okay. Now this can be written as cos square theta into hyperbolic sine square phi minus sine square theta into hyperbolic cos square phi. This is equal to 1. But we have to prove cos 2 theta into hyperbolic cos 2 phi is equal to 3. So this cos square theta into hyperbolic sine square phi, that is nothing but hyperbolic cos square phi minus 1. Okay. Minus 1 minus cos square theta into hyperbolic cos square phi. This is equal to 1. Okay. Again, taking multiplication, cos square theta into hyperbolic cos square phi minus cos square theta minus hyperbolic cos square phi minus plus cos square theta into hyperbolic cos square phi. This is equal to 1. Okay. Now we can collect this term and this term. Then we can write this as 2 times cos square theta into hyperbolic cos square phi minus cos square theta minus hyperbolic cos square phi. This is equal to 1. Okay. So we can write this as 2 times hyperbolic cos square phi, taking cos square theta common, minus 1 into cos square theta. Okay. Minus hyperbolic cos square phi, we are replacing by hyperbolic cos 2 phi plus 1 divided by 2, and this is equal to 1. Okay. Now twice hyperbolic cos square phi minus 1, this is equal to hyperbolic cos 2 phi. Multiply both sides by 2, so we can write 2 times hyperbolic cos 2 phi into cos square theta. Okay, into cos square theta minus hyperbolic cos 2 phi minus 1, and this is equal to 2 into 1, 2. Okay, take this minus 1 on this side and take hyperbolic cos 2 phi common from these two terms. So 2 times cos square theta minus 1 into hyperbolic cos 2 phi is equal to 2, and this one taken on this side, this becomes 3. Okay, now 2 cos square theta minus 1 is what? Cos 2 theta. Hence we can write cos 2 theta into hyperbolic cos 2 phi. This is equal to 3, which is our result, which we have to prove. Let us solve next sum. Sum number 2. If tan of alpha plus I beta is equal to cos theta plus I sin theta, then prove that alpha is equal to n pi by 2 plus pi by 4 and beta is equal to half of logarithm of tan of pi by 4 plus theta upon 2. Concentrate on this n. Period of tangent function is pi. We have to add n pi in theta so that we will get general form of theta or amplitude of this complex number. Okay, so let us solve this sum. First of all, given that tan of alpha plus I beta is equal to cos theta plus I sin theta. Tan of alpha minus I beta will be equal to cos theta minus I sin theta. Okay. Now alpha plus I beta plus alpha minus I beta. This is equal to 2 alpha, and alpha plus I beta minus alpha minus I beta is equal to 2I beta. Now tan of A plus B is equal to tan A plus tan B divided by 1 minus tan A into tan B. Now tan of alpha plus I beta plus alpha minus I beta is equal to tan of alpha plus I beta plus tan of alpha minus I beta divided by 1 minus tan of alpha plus I beta into tan of alpha minus I beta. Okay, tan 2 alpha is equal to tan of alpha plus I beta is cos theta plus I sin theta. Tan of alpha minus I beta is cos theta minus I sin theta. Addition of these two, that is 2 cos theta divided by 1 minus tan of alpha plus I beta into tan of alpha minus I beta, that is equal to cos theta plus I sin theta into cos theta minus I sin theta. This is what? Cos square theta plus sin square theta, and which is equal to 1. So This can be written as cos square theta plus sin square theta. Hence, this is equal to 2 cos theta upon 0. Okay, this is equal to infinite. Hence, 2 alpha is equal to tan inverse infinite. This is equal to pi by 2. Pi is period of tangent function. Adding n pi on right hand side, that gives general amplitude. So 2 alpha is equal to n pi plus pi by 2. This is general form. Alpha is equal to, taking this 2 on right hand side, n pi by 2 plus pi by 4, which is statement which we have to prove. Now we are going to prove second result, that is beta is equal to 1 upon 2 logarithm of tan of pi by 4 plus theta upon 2. Okay, let us prove this result. Now tan of alpha plus I beta minus alpha minus I beta. This is equal to tan of alpha plus I beta minus tan of alpha minus I beta divided by 1 plus tan of alpha plus I beta into tan of alpha minus I beta. But you know, tan of alpha plus I beta is cos theta plus I sin theta, and tan of alpha minus I beta is cos theta minus I sin theta. Alpha plus I beta minus alpha minus I beta, left hand side becomes tan of 2 times I beta, and right hand side cos theta plus I sin theta minus cos theta minus I sin theta, that is 2I sin theta divided by 1 plus cos theta plus I sin theta into cos theta minus I sin theta, that is cos square theta plus sin square theta. Cos square theta plus sin square theta. But you know, cos square theta plus sin square theta is trigonometrical identity, which is equal to 1. So tan 2I beta is equal to 2I sin theta divided by 1 plus 1, 2. 2 gets cancelled. I sin theta is equal to tan of 2I beta. But you know, tan Ix is equal to I into hyperbolic tan x. Now, using this result, this can be written as I into hyperbolic tan 2 beta. Now, I gets cancelled. Hyperbolic tan 2 beta is equal to sin theta. Okay. Now, taking this hyperbolic tan on right hand side, 2 beta is equal to hyperbolic tan inverse sin theta. But you know, hyperbolic tan inverse x is equal to 1 upon 2 logarithm of 1 plus x divided by 1 minus x. This is equal to 1 upon 2 logarithm of 1 plus sin theta divided by 1 minus sin theta. Again, we know trigonometrical result, cos theta upon 2 plus sin theta upon 2, square of this is equal to 1 plus sin theta, and cos theta upon 2 minus sin theta upon 2, square of this is equal to 1 minus sin theta. Okay, so 2 beta is equal to, we can write 2 beta is equal to 1 upon 2 logarithm of cos theta upon 2 plus sin theta upon 2, its square, divided by cos theta upon 2 minus sin theta upon 2, its square. Okay, now 1 upon 2 logarithm of cos theta upon 2 plus sin theta upon 2 divided by cos theta upon 2 minus sin theta upon 2 its square. Okay. Now by the property 2 we can take here. Then logarithm of cos theta upon 2 plus sin theta upon 2 divided by cos theta upon 2 minus sin theta upon 2. Okay. Now take this 2 on right hand side. Beta is equal to 1 upon 2 logarithm of. Now divide numerator by cos theta upon 2 and divide denominator also by cos theta upon 2. Then we can write 1 plus sin theta upon 2 divided by cos theta upon 2, that is tan theta upon 2, divided by 1 minus tan theta upon 2. Okay. But tan of pi by 4 plus theta upon 2 is equal to 1 plus tan theta upon 2 divided by 1 minus tan theta upon 2, because tan pi by 4 is 1. So beta is equal to, we can write 1 upon 2 logarithm of tangent of pi by 4 plus theta upon 2. And this is second part which we have to prove. Okay, in this way first part as well as second part we have proved. Let us solve next sum. Sum number 3. Separate into real and imaginary parts tan inverse of alpha plus I beta. Let us assume tan inverse alpha plus I beta is equal to, suppose, x plus iy. Here we have to find out x and y. Okay. Now taking this tan inverse on this side, alpha plus I beta is equal to tan of x plus iy, and alpha minus I beta is equal to tan of x minus iy. Okay. Now x plus iy plus x minus iy is equal to what? 2x. And x plus iy minus x minus iy is equal to 2iy. Hence tangent ratio of x plus iy plus x minus iy, this is equal to tan of a plus b formula, that is tan of x plus iy plus tan of x minus iy divided by 1 minus tan of x plus iy into tan of x minus iy. Put the values. Tan of x plus iy is alpha plus I beta. Tan of x minus iy is alpha minus I beta. Put here. And x plus iy plus x minus iy, that is equal to 2x. Hence left hand side becomes tan 2x is equal to alpha plus I beta plus alpha minus I beta divided by 1 minus alpha plus I beta into alpha minus I beta. And here I beta gets cancelled. 2 alpha divided by 1 minus alpha plus I beta into alpha minus I beta, that is alpha square plus beta square. So we can write alpha square plus beta square. Okay. Now tan 2x is this, then 2x is equal to tan inverse 2 alpha divided by 1 minus alpha square minus beta square. Hence you can separate x, which is real part of given complex number. X is equal to half tan inverse 2 alpha divided by 1 minus alpha square minus beta square, which is a real part of tan inverse alpha plus I beta. Now tan of x plus iy minus x minus iy. This is equal to tan of x plus iy minus tan of x minus iy divided by 1 plus tan of x plus iy into tan of x minus iy. Left hand side becomes tangent ratio of 2iy is equal to alpha plus I beta minus alpha plus I beta divided by 1 plus alpha plus I beta into alpha minus I beta, and this is equal to 2I beta divided by 1 plus alpha square plus beta square. Tan Ix is equal to I into hyperbolic tan x. Okay, so left hand side becomes I into hyperbolic tan 2y, and this is equal to 2I beta divided by 1 plus alpha square plus beta square. I gets cancelled. Hyperbolic tan 2y is equal to 2 beta divided by 1 plus alpha square plus beta square. Okay, and then 2y is equal to hyperbolic tan inverse 2 beta divided by 1 plus alpha square plus beta square. Hence, taking this 2 on this side, y is equal to 1 upon 2 hyperbolic tan inverse 2 beta divided by 1 plus alpha square plus beta square, and this is imaginary part of tan inverse alpha plus I beta. Okay, in this way we have obtained real part and imaginary parts of tan inverse alpha plus I beta. Let us solve next sum. This is sum number 4. Prove that hyperbolic sine inverse tan theta is equal to logarithm of tan of pi by 4 plus theta upon 2. We have to prove this. So to solve this sum, hyperbolic sine inverse x, this is equal to logarithm of x plus square root of x square plus 1. Hence LHS is equal to hyperbolic sine inverse tan theta, and this is equal to logarithm of tan theta plus square root of tan square theta plus 1. But 1 plus tan square theta is sec square theta. Logarithm of tan theta plus square root of sec square theta. And this is equal to logarithm of tan theta plus sec theta. Now logarithm of sin theta upon cos theta plus sec theta is 1 upon cos theta. LCM is cos theta. Logarithm of, we can write 1 plus sin theta divided by cos theta. Okay, and now 1 plus sin theta is equal to cos theta upon 2 plus sin theta upon 2 square of this. Okay, and then cos theta is equal to cos square theta upon 2 minus sin square theta upon 2. So cos theta can be written as cos theta upon 2 plus sin theta upon 2 into cos theta upon 2 minus sin theta upon 2. Hence LHS is equal to logarithm of, we are replacing 1 plus sin theta by this cos theta upon 2 plus sin theta upon 2 square of this divided by, in one bracket, cos theta upon 2 plus sin theta upon 2, and in another bracket cos theta upon 2 minus sin theta upon 2. Now we can cancel this square with this bracket. Then we can write logarithm of cos theta upon 2 plus sin of theta upon 2 divided by cos theta upon 2 minus sin of theta upon 2. Now divide numerator by cos theta upon 2, denominator by cos theta upon 2. Then this can be written as logarithm of into bracket cos theta upon 2 divided by cos theta upon 2 1 plus sin theta upon 2 divided by cos theta upon 2, that is tangent of theta upon divided by cos theta upon 2 divided by cos theta upon 2 1 minus sin theta upon 2 divided by cos theta upon 2 tangent of theta upon 2. But you know tan of pi by 4 plus theta upon 2, this is nothing but 1 plus tan theta upon 2 divided by 1 minus tan theta upon 2. Okay, so you can replace this by logarithm of tangent of pi by 4 plus theta upon 2, and this is equal to right hand side of the statement which we have to prove. You can check this left hand side and this is right hand side. Hence this is proof of this statement. Thank you all, thank you very much. If there is any correction, please make the correction and put it in comment box. Thank you.